Good morning and once again welcome to my YouTube channel Maths with Ease by Mr. Kamotho. And in this video we want to explain example 6 of Algebra 9 whereby we are supposed to prove that the difference between the squares of any two consecutive integers is equals to the sum of these integers. In this question, you realize that I have underlined some keywords here. The difference, we know how to get the difference after subtracting one number from another. Between the squares, we know how to get the squares. We simply square a number to get its square. Of any two consecutive integers, I ought to have underlined consecutive integers is equals to the sum. Let's have consecutive integers is equals to the sum of these integers, the sum of these integers. Difference between the squares of any two consecutive integers. Let the first integer be n. If n is the first integer, the other integer has to be n plus 1 because the two consecutive integers in general, the difference is only 1. If n is 3, then the second integer is 3 plus 1, which is 4. If n is 10, the second integer is 10 plus 1, which is 11. We are talking about 20, 21. We are talking about 40, 41, 59, 60. That is exactly what we're talking about. The squares of these numbers and the differences. So we must have n plus 1 squared. This is the same as n plus 1 multiplied by n plus 1. And as we know, we can use the FOIL in opening the brackets, where FOIL means first, outer, inner, and last. First, outer, inner, and last. So for the first terms, we get n times n squared, n times 1 plus n, inner 1 times n plus n, and the last 1 times 1 plus 1. This becomes n squared plus 2n plus 1. The square of the first integer is simply n squared. Now, if you look at the question again, the difference between the squares is actually this one minus this. So we have n squared plus 2n plus 1 minus n squared. So that one goes with that, and we have 2n plus 1 is equal to the sum of the two integers. Is this true? The first integer is n, the second integer is n plus 1. The first integer is n, the second integer is n plus 1. If you add this together, is actually 2n plus 1, which is exactly equals to that. And we have actually proven that. So prove that the difference between the squares of any two consecutive integers is equals to the sum of these integers. We have done that. This is the square of one integer. This is the square of another integer. When we subtract one from the other, we get this, which is basically the sum of the two original integers. And that is just that. Thank you, and let us meet in the next video.